Okay, students, today we are going to discuss a very important chapter of the operation research, which is called basically the transportation problem. Basically, you know that in our real world, everything dependent on the transportation. So, the transportation problem act as a vital role in the optimization theory. You know that optimization means if there is some profit, we will try to maximize it. If there is some loss, we will try to minimize it. So that is the basic optimization procedure basically. So in the transportation problem, as you know that so many things can be produced in different places and that cannot be used by the same places. So it can be used by the some companies or anything in the different places. So the material should be transported from the origin to the destinations. So the transportation cost is involved here. And relating to this, basically the transportation problem we are going to discuss. That what is the way to minimize the transportation cost. Sometimes also transportation problem can be defined as the in terms of the profit. So later on I will discuss what is the different type of the transportation problem. But initially we are going to discuss what is the transportation problem. So in the transportation problem, basically there is some origin. So this is our origin and this is our destination. Now, from origin to destination, this is our ith origin, this is our jth destination. So, from ith origin to jth destination, if you want to transport 1 unit of any material, what is the cost needed? That is defined as Cij. This is from ith origin to the jth destination. Why I am saying ith origin, jth destination? Because you know that same material can be produced in different places and the same material can be needed in the different destinations also. So that's why we are defining that ith origin and jth destination. Okay. Now we are considering the transportation of some material. We are considering the transportation of the material, what is basically consist of three origin and three destinations. It may be any number of origin, it may be any number of destinations. So this is your first origin, this is your second origin, this is your third origin. We are nomenclated this as A1, A2 and A3. This is the destination 1, 2, 3, and we can consider these as B1, B2 and B3. Okay. So this is basically the transportation cost from one to this. We will denote this as by C11. This cost is C12 and so on. Okay. So depending on these things, basically we are able to transform this is in the form of a matrix representation. Okay. So that we will do here later on. So first I am discussing what type of okay. So let's go for the next slide. So here we are basically discuss that what is the transportation problem, that the material which can be transported by in terms of several techniques we are following in our present situation. different type of technique we are using for the transporting the material from one place to the another places. Okay. Now, transportation problem is of two types. One is called minimization problem, another is maximization. As I told you earlier, that if the transportation cost is given for transporting some material from one place to another place, what is the transportation cost per unit? It is given. At that time, as a person, as I am spending some money for the transportation cost, so our aim will be to minimize the transportation cost. But in some cases, not depending on the cost, it may be given in terms of the profit. That if we transport one unit from here to this destination, then the profit will be this. So at that time, as the matrix representation and the elements of them are presenting the profit, so we'll try to maximize it. So that's why we categorized two transportation problem of two type. One is minimization type, another is maximization type. So if we know the technique to solve the minimization problem, then only extra one step will be involved to transform the maximization problem into the minimization problem. So that's why we are first focusing on the minimization problem, and then we just transport this on the second slide. Okay, am I clear? Now let's go for the other features. So some terms we are using here in the transportation problem. One is called feasible solution. Feasible solution means basically the non-negative solution. Obviously, if you transport, you can't say that we transport -2 unit from this place to this place. So due to that reason, this condition is always enclosed that whatever the solution you are writing, that must be positive, non-negative. It may be zero, so that's why we are saying that non-negative. Because non-negative means it can be zero or positive. Positive means only the positive value we are considering. So that's why feasible condition means basically whatever the amount you are transporting, that should be the greater than or equals to zero. Next term is called basic feasible solution. Whatever the solution you are getting, that should be the basic solution. So basic solution means linearly dependent, independent, these terms are involved there. I am not going for that. Only the straightforward case, if the number of allocations is equals to the m plus n minus 1, then we are saying that the feasible solution you are getting. Now the question is what is m, what is n? M is called the number of origin, and n is the number of destinations. Okay, so this is number of origin and this is number of destination is called basically the n. Now, optimum solution. Optimum solution, today we are not going for the optimum solution, we will first go for the basic feasible solution. How we find out this. And later on we will discuss that how we find out check it out that whatever the solution we have find out, that is the optimum one. Optimum one means no such solution exists which crosses the main result. Okay, so that we will see later on. Now, when you are going to solve the transportation problem, at that time we will first check whether it is balanced or unbalanced. Balance and unbalance depends on the available amount in the origin. What are the number of units is available in the origin, and what is the number of units demanded by the destination. There is 4 project is going on, and for that the cement is needed, and the cement is distributed from the three origins. So in 3 origin, let 100 bags of cement is there, first origin. Second origin contain 500 bags of cements, and origin 3 contain 700 bags of cements. So these are called the available amount in the origins. And as different projects needed different demands, so that's why these units also be predefined. Okay. Project 1 needed 150 bags of cement. Project 2 needed 700 bags of cement. Project 3 needed 200 bags of cement. Project 3 needs 50 bags of cement. So these values are basically called the demand of the destination. Okay. Now if the sum of the available amount is equals to the sum of the demand amount in a particular transportation problem, then we call that the transportation problem is a balanced transportation. If it is not, then it is not balanced. Now, in the next slide we will discuss that if the problem is not balanced, we can't solve it. So first we will make it balanced, then we will solve it. Okay, so how will do that? Then I will go for the next slide. Then the matrix terminology means there will be a matrix representation, and in general in the matrix row represents the origins and column represents the destinations. Okay, so origins, if we go for the matrix representation, we will see that this is our origin 1, origin 2, origin 3, then you can say this is your destination 1, destination 2, destination 3 and destination 4. Okay. Now here we will write down the available amount A1, A2, A3. This is called B1, B2, B3. Okay, so these are called the available amounts. This is called the demand of the destinations. And to transport one unit from one origin 1 to destination 1, we can say that the cost needed is C11. To transport one unit from origin 1 to destination 2 is C12, C13, C14 and so on. So this will be C32, this will be this will be 3, 4. So this is the nomenclature we are using here in the matrix representation. Okay, so C11 is the cost to transport one unit from origin 1 to the destination 1. That is why Cij is the cost needed to transport ith origin to the jth destination for one unit. Okay, so let's go for the next slide. So that's why our main transportation problem is what? The transportation problem, whatever is given to us in general, it should be minimized. If it is not dependent on transportation cost, it is dependent on profit, then obviously it should be maximized. On that case, only one step will be added to transform the maximization problem into the minimization. Okay. Now, if the transportation problem is unbalanced, then what we are saying? What we will do? So if it is unbalanced means the total demand is not equals to the total supply amount. So either demand is greater than supply. So if demand is greater than supply, then we have to add a dummy column in the matrix where the transportation cost we will nomenclature as 0. Because the transportation has not been done out there, so the transportation cost will be 0. Similarly, if the supply is greater than demand, then we will add a dummy row in the matrix with zero cost. Okay. So this is the way to transform a unbalanced transportation problem into a balanced transportation problem. And then we will go for the solution technique. So I have given one example where you can see that there is A, B are the two origin, P, Q are the two destinations. These are the transportation cost to transport one unit from origin A to the destination P. This is 10 unit. This is 15 unit. This is 20, sorry, rupees 20, rupees 10, rupees 15, rupees 30. This is the available amount in the origin A. This is the available amount in the origin B. And this is the demand of the destination P, and this is the demand of the destination Q. Now you can add these two terms, you will get this is 70, and if you this, then you will add these two, you will get this is 90. So basically, the demand amount and the supply amount are not equal. So at that time, you can see that the demand is more than the supply. So in this case, what we will do? At that time, we will add a dummy row, or you can say dummy origin, whose transportation cost is also are zero, but we are considering that the dummy origin has 20 units of supply. Dummy origin has 20 units of supply. So on that way, now you can see that the supply amount and the demand amount are same. So we can go for the next process, means the solution of the technique. So let's check it out. If supply is greater than demand, then what will happen? So here you can see that the supply is 90 unit, demand is what? 70 unit. So at that time, we have to add a dummy destination, and we will say that the demand of this destination is 20 unit, so that this becomes a balanced problem. Am I clear? So before solving the transportation problem, this is the first step and the initial step, very important. You have to check out whether the transportation problem is balanced or not. If not, make it balance. Then go for the further steps. Means the technique for solving the transportation problem. So, to find out the solution problem, basically we first find out the step 1, which is called the initial basic feasible solution. That we will do first. Okay. Second step, to find out, check it out whether it is optimum or not. So that we will do on the later classes. Okay, next class, maybe day after tomorrow, we will go for this case. So first case is we will find out the initial basic feasible solution. Now the initial basic feasible solution can be find out these three different ways. One is called northwest corner method, NWCM. Another is called lowest cost entry method. Sometimes it is also called matrix minimum method. And last one is called the Vogel's approximation method, or HAM. Okay, so these three different techniques we will learn, and at last we will see that the Vogel's method is the best one. But initial stage, we are going to find out what? These two steps, where we will learn that how we are going to find out the solution. Maybe in the next class we will go for the Vogel's method. Let's see. Obviously, to compare the results, what I have done here, I choose only one problem by which or over the problem we will apply the same these three different techniques. And at last we will check out that what method is the best one. Okay. But initially the northwest corner method has been started. Then it has been modified into the matrix minimum method, the lowest cost entry method. Then they think about the Vogel's approximation method. Okay. So let's check it out. What is the northwest corner method? Okay. I am directly going for the. So these are the steps I have written here. Basically, first step क्या है? First step we will construct the matrix from the given transportation problem, which consists of m origin, n destination. So we are able to construct a m cross n order matrix that we will first construct. Then we will check it out whether it is balanced or not. If it is not balanced, make it balanced. After that, for any matrices, you can see here in this, I have done this. You can see that this is the northwest corner. If you delete this row or delete this column, then you will find out a new matrix, and then you are able to find out the new matrices के लिए what is the northwest corner. Okay, so that's I am going for the okay. So that's we have going for the second, third step. That starting from one cell at the northwest corner of the matrix, we will go for the allocation. Now, in this process, what is the maximum amount we will allocate? So that things I think will be more clear to you if I go for the problems. Let's see. I have chosen here three origin, three destination. This is what the 7 unit, sorry, to transport one unit from plant 1 to the warehouse W1, 7 rupees 7 will be the per unit cost. This is rupees 6 is the per unit cost to transport one unit from plant 1 to warehouse 2, and so on. So these portions basically are the these values are basically the transportation cost amount to transporting one unit from one origin to the another destinations. These are the available amounts in the origins. These are the demand. Now we can check it out that sum of these will be what? This is 5, then 2 to 4, 65. This is 10, 5, 15, 2 to 4, 5, 6. This is also 65. So the problem is balanced. As the problem is balanced, now we can go for the solution technique that we are going to find out here. Let's check it out. Okay. Now, what we are doing here? What is the northwest corner of this matrix? This is our northwest corner of the matrix. So in this corner, we will go for our first allocation. Now the question is what amount we will transport here? The available amount is 20, the demand amount is 21. So maximum 20 unit we can transport from origin 1 to the destination 1. So if we do this, we can see that we have completed all the available amount in the planned 1. So in our present picture, planned 1 is not present. But warehouse 1, 20 unit you have given, so 1 unit till they are demanding. Their demand is till 1 unit. So now you have a matrix with 2 origin but 3 destination. So what is the new matrix? The new matrix is nothing but this one. So in the new matrix, what is the northwest corner? This is your northwest corner. Demand is 1 unit, available is 28, so you can transport only 1 unit here. So when you transport 1 unit here, you have fulfilled the demand of the warehouse 1. But as you transported 1 unit here, so the plant 2 has now 27 unit left in their plant. So now you can see this is a 2 cross 2 order matrix and this is our northwest corner. So in this northwest corner, the demand is 25, available is 27. So maximum amount we can transfer what? Yes, 25 unit. Very good. So this is your 25 unit. So when you are doing this, you can see that you have fulfilled the demand of warehouse 2. And for that, 25 unit already you have transported from plant 2, so only 2 unit is left. Okay, and the new matrix is what? Is 3, 8. So 2 row, 1 column. What is the northwest corner? What amount we can send? Available is 2, demand is 19. So this is 2 unit, and at last there is no other way. That will be what? 17. As it is balanced, it must coincide. Don't think that it will not be that. So ultimately we are getting allocation, so that I have shown here. See, in the first step it is balanced. Okay. Next, what is the northwest corner? This place is the northwest corner. So available amount is 20, demand is 21. So we gone for the allocation 20 unit here. Rest amount is here. This is 1. इसका काम खत्म. So what is the next step? Next step you can see that you have taken all these amounts. So basically, just a minute. Yes. So 1 unit will present here. After that, you have completed his work. You have completed this one also. So remaining portion is 27, remaining matrix is this, and then we are going for the next slide, where you can see that 25 unit you are putting, so इसका demand खत्म, remaining amount is 2 unit, so that we are putting here, and to balance, as it is balance problem, so 17 unit we will go there. So here number of row is 3, number of column is 3, so the allocated cell should be what? M plus N minus 1. I told this that it should be M plus N minus 1. So let's see, 1, 2, 3, 4, 5. So 3 plus 3 minus 1, which is equals to 5, which is the number of allocated cells. Am I clear? So this is the way to find out the what unit we will transport from which origin to which destination, so that the overall transportation cost we can find out. What will be the overall transportation cost? Rupees 7 into 20 unit plus rupees 5 into 1 unit plus rupees 7 into 25 unit plus rupees 3 into 25 unit plus rupees 8 into 17 units. That will be our total transportation cost. So you can find out how we find out the total transportation cost. In total it is 462. So total transportation cost is 462 when we are following the northwest corner method. Now I am going for the second technique, which is called the least cost entry method, or sometimes it is called matrix minima method. This is also the same procedure, but the new concept. New concept means basically, as we want to transport we want to minimize the transportation cost. So we are searching that in which cell the minimum cost is present. If there is a cell of minimum cost, transportation cost is minimum, we are first to go for the allocating that cell, so that the maximum amount we can transport there with the minimum cost, and at that time the overall cost will be the minimized. That is our motto. So for that we follow the same technique basically. So the same problem I have chosen here, it is balance problem. Now let us see what is the minimum cost present here. In this case you can see that the minimum cost is 3. So if minimum, as you can see that in the matrix the minimum cost is 3, so we first aiming to transport here. This is our first step to transport at that cell, because the transportation cost is minimum on that cell. Means to transport 1 unit from P2 to W3, the transportation cost is rupees 3 per unit. So at the minimum cost, if we transport maximum amount, that will be minimize the overall transportation cost. On the basis of that, what we are doing here, you can see that P2 available is 28, demand is 19. So maximum what amount we can transport? 19 amount. So when we do this, we have done the demand of W3. Means in the new matrix, W3 will be not there. But P1, P2, P3 will be there, where P1's available amount is now only 9 unit, because 19 unit already you have taken. So only 9 units there. So you can see that now in these cases, over the new matrix does not have this column, only these two column, these three row. So among these, what is the minimum cost? You can see that the minimum cost is rupees 4. So as the minimum cost is rupees 4, you are going for the allocating there. So what amount you can allocate here? Yes. Demand is 21, available is 17. So maximum we can transport is 17 unit. And when we have done this, we have no choice of P3 because P3 has no available amount. But W1 का जो demand we have fulfilled 17 unit, so 4 unit still we have to send for W1. Am I clear? So now in the new matrix consists only P1, P2, W1 and W2. What is the minimum cost? Minimum cost you can see now. What amount you can send it here? Demand is 4, available 9. So you can transport 4 unit here. So इसका भी काम खत्म. Only the 2 cells are remaining. 4 unit we have sent it. So here 5 unit is remaining. Only 2 cell is remaining here. Minimum is 6. Maximum we can transport 20. Or last, this is the only cell where we can send it 5 unit. So that whole process I have discussed 1 second. You can see the minimum cost is 3. So 19 unit we have sent it there. Next case में whatever the process I have defined, that has been done here. Okay. So by this way, we are able to find out that what amount has been transported from which origin to which destination. Am I clear? So everything we have, whatever I have discussed earlier, that has been written here. Now see, what is the number of allocated cell? M plus 1, 2, 3, 4, 5. 1 second it is M plus N minus 1. As it is balanced, it should be there. In some cases, it may not be. So that thing we will discuss later on. Okay. So you can see now final matrix with the allocation and what is the number of row, number of column is equals to the M plus N minus 1 and the transportation cost. Once again, if I go there, you will see 20 unit at the rate of rupees 6, 4 unit at the rupees of 5, 5 unit at the rupees of 7, 19 unit at the rupees of 3 and 17 unit at the rupees of 4. So that value we have found here and the total cost what we have seen 300 rupees. So by these two techniques, we are applying the same problem what we have seen. We have seen that matrix minimum method or least cost matrix method basically gives you the better result than the northwest corner method. Okay, so later on we will see that another method which is called the Vogel's approximation method. There you will see what that method is better than this one also because that is depending on a different concept. Okay, so that we will see on a later class. So that is for today. If you have any question, you can ask me. Okay, thank you everybody. Thank you.